To solve this, you can first add 1 both sides and divide by 2, which says I have to look for the x value where cosine of x has to be 1/2, which means I need to use the graph of cosine. The graph of cosine, hopefully you've drawn this several times so that it feels very easy for you. Okay. The graph of cosine is 1, 0, -1, 0, and then 1. That's the graph of the cosine. And because it's a periodic function, this actually extends on the left and right by copy and paste. You can copy this and paste it over here, which will be like that. Now notice that in this question, x is not the usual 0 to 2 pi. X is between -pi to pi. So the actual place that we have to search for is not from here to there, but it's actually from -pi until pi. So it's this portion of the graph. Okay? All right. Now how do we look for the place where the value of the cosine is 1/2? Well, first you have to recognize that the value of 1/2 is what we call the small value in the special angle. So we talked about how cosine and sines have values that look like this at special angles, multiples of 30 degrees, 45 degrees, and 60 degrees. Their values are 1, 2, 3, so it's very easy to remember. And this, I'm purposely writing it like this, but square root of 1 is 1, so this really is just 1/2. And we say this is small, this is medium, and this is large. And that means we're looking for the small size. Okay, those 3 values are always in each of the quadrants. So every quadrant will have 3 sticks, 3 sticks, 3 sticks, 3 sticks. Okay, so from -pi to pi, there are 3 sticks in each quadrant, which means each 90 degrees. So this is -180 to -90, there's 3 sticks. There are 3 sticks. From -90 to 0, there are 3 sticks. 0 to 90 degrees, 3 sticks. 90 degrees to 180 degrees. Remember, pi radians is 180 degrees, right? So this is, in between here, you have 3 sticks. Okay. And these 3 sticks really correspond to those as small, medium, large. So the smallest guy would correspond to 1/2. The largest guy will correspond to radical 3/2. Is this okay? Okay? Alright, so let's see, where do we get the 1/2? Those are the small guys, right? So I see that there's the small guy here, another small length here. Of these 3 lengths, this is the smallest, right? So there's one here, there's one here. On the other hand, there's also this one and this one, but they don't count because those are going below the x-axis, which means that the value of these functions are negative. So if this was -1/2, then you would be choosing these, but right now it's +1/2, so these are the only ones that you choose. Okay? All right, so we identify that these are the places where the cosine becomes 1/2, but we're really looking for the x value, not the y value. We're looking for the x value. So what does that mean? That means I'm looking for this x value. What are these points? That's my question, okay? And when you go through these, you have to remember that these are the special angles, so these are like 30 degrees, 45 degrees, and 60 degrees. Okay, so which one of these 3 gives you 1/2 at the cosine? Which degrees? 30 or 45, 60? Which one? 60, right? It's the 60 degree one. So at first we see that when x is 60 degrees, the cosine of 60 degrees will give you 1/2. But there's another one. What is this one?
30.
What? Yeah, which one is it?
30. 60.
Well, it's, okay, it says 30, 45, 60, that's right. But that one starts from negative 90 degrees, right? Right, this is 0, 90, 180, negative 90, negative 180. Okay? Pi is 180 degrees, and pi radians is 180 degrees, so negative pi is negative 180 degrees. This is negative 90 degrees. Okay? Okay? So if you have negative 90 degrees plus 30 degrees, where is this?
Negative 60.
Negative 60, right? So you can think of this as negative 90 degrees, and you go right by the smallest amount. Remember, 30, 45, 60. So you're adding 30 degrees to this one, which gives you negative 60 degrees. So I know that negative 60 degrees is another place. Now you could also have figured this out by just looking at the symmetry. So this is 0. This place is 0. So if this is 60, then this must be negative 60, because there's a symmetry, right? Yeah. So that will be another quicker way to figure out that this is negative 60. But either way, once you've figured out that these are the angles, that's great. However, we need to answer in radians because the original values are given as radians. So you're not going to get full credit if you stop here. Let's change this to radians. How do you change degrees to radians? How do you change degrees to radians? You multiply by pi over 180 degrees, right? And because degrees cancel, and 180 is 3 times 60 degrees, so if you reduce these two, you end up with a 3. So you can say that 60 degrees is same as pi over 3 radians. That means negative 60 degrees must be equal to negative pi over 3 radians. That means that the answer to this first question is pi over 3 and negative pi over 3. Yes?
So you would solve... Oh wait, no, never mind.
Yeah, we were looking for the x value that would make this true. And if x is pi over 3 or negative pi over 3, this will compute to 0.
Okay.
All right. Okay, similar question. You subtract 2 radical 2, both sides. And now you divide both sides by 4. Which, if you reduce 2 and 4, you get negative radical 2 over 2. Okay, what's the nickname for this value? We call this what?
Is it?
We call this what value? Medium value, right? It's the medium value. We're calling it a small, medium, large. It's the medium value, right? So we're looking for the median value in the graph of sine. Let's make sure that we know the graph of sine. If you honestly studied for the exam, you would be graphing this more than 20 times. Okay? If you haven't done that, that probably means that you didn't prepare enough for the exam. Okay? All right. So this is the graph of the sine. So you have to graph sine. You have to graph cosine. These should be automatic. Whenever you're asked to draw it, you should easily draw them. Okay? So that's the graph of sine. Again, 3 sticks every quadrant. And it's the medium going down. Because of the minus, it's the medium negative size. That means we're looking for this guy right here and this guy right here. Okay? In both cases, it's the middle guy, which is the 45-degree one. Okay, so let's try to identify the angle. Remember, pi is 180 degrees. So what would this be? 180 plus 45, which is?
225.
225, yes. That will be 225 degrees. Okay. Now this one here, 3 pi over 2 is 180 plus 90 degrees, which is 270 degrees. Which means this point is? 270 plus 45?
315.
315. Okay? So we see that at 225 degrees and at 315 degrees, sine becomes negative or equal to over 2. Okay? But again, you have to convert that to radius. And as I said, you have to multiply degrees to pi over 180 to get the radius. So that's one way to do it. But, when it comes to special angles, you should just memorize that 45 degrees is pi over what? Pi over? Pi over? Pi is 180 degrees. If you divide by 2, you get 90 degrees. Pi over 2 is 90 degrees. 45 degrees would be pi over?
4.
4, yes. Because it's half of half. Half of 90 degrees is 45, right? So you take 180 degrees, you take half of half, you get 45 degrees. So this is something that you should just remember. And then say 225 degrees is 45 degrees times what? So 225 is equals to 45 degrees times 5, right? 5 times 5 is 25, 5 times 4 is 2. So 5 times 45 is 225, which means it'll be 5 times pi over 4. So 225 will be 5 pi over 4. I don't have any room, so let me write over here. 315 degrees would be what times 45 degrees? 45 times what? 7 of them, okay? You can even picture it too. If you have this circle, here's 45, then just count how many. 1, 2, 3, 4, 5, 6, 7. This is 315, right? So it requires 7 pieces of 45 degree pizza. Okay? That's a quick way to figure it out. Rather than having to calculate this, it's more intuitive, okay? So this is 7 times 45, which means you get 7 pi over 4. Because 45 degrees is pi over 4, you have 7 pi over 4. Okay, so therefore what is the answer? Answer would be x equals to 5 pi over 4 and 7 pi over 4. Yeah, that's how you do it. Okay. Suppose that theta is in the standard position. Now, what does that mean? Well, standard position means the usual way you put the theta on the unit circle. So on the unit circle, you have some angles like that, right? Here's the angle. Some angle could be like this. So that's what it means to be in the standard position. And here it says there's the point -8 comma +6, so this point right here, where, let's say this is the unit circle, where the angle theta is ending. So here's this angle theta, and at the end of the angle theta, there's this -8 comma 6. And the question here is to find the value of sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. 6 functions, 6 trig functions are defined at theta. Find all of them. That's the problem. Okay, such a question can be answered in terms of the reference triangle. Reference triangle is the triangle that you draw towards the closest point in the x-axis. And instead of using this angle theta, you use this other angle. So if you try to find the angle of trig functions of this angle theta, not this one, the red theta than the black theta, if you do that, the values of trigs are exactly same as the values of trigs on the other black one, except for the sign. So the signs could be the opposite, right? Okay, so you can use this reference triangle to figure out the sine, cosine, tangent, and then you have to determine the sign later. But instead of trying to figure out what these lengths are, it's easier to use this bigger triangle. Because after all, what is sine, cosine, tangent? Those are ratios of sides of a right triangle, right? For example, sine is opposite length divided by the hypotenuse length. So it's the ratio of the lengths of a triangle, okay? When it comes to ratios, if you have two like triangles, the ratios are the same. Whether you do, say, this length divided by this length, the same thing as this length divided by this length, because these two are like triangles. You learned that in high school geometry. Yeah. Would you believe that? Yeah. Kind of makes sense, right? Okay. So let's assume that we believe that, and we're just going to find out the ratios of this right triangle, the bigger one. Now, because this is -8, this length would be 8. And because this is 6, this length would be 6. And now the question is, what is the hypotenuse length? How would you find the hypotenuse length? Pythagorean theorem, yes. So you do 6 squared plus 8 squared equal to c squared. 6 squared is 36. 8 squared is 64. 36 plus 64 gives you 100 as c squared. So c must be square root of 100, which is 10. So we just figured out that this length is 10. Once you know that this is 10, now let's try to find the cosine, or let's start with the sine. SOHCAHTOA, right? Sine of theta would be what over what? Opposite of this angle theta is 6. Hypotenuse is 10. So it will be opposite over hypotenuse. SOHCAHTOA. Remember, it's SOHCAHTOA. And we have this one opposite over hypotenuse. Okay. But as I said, we're really using the red theta, not the black theta, right? So if you want the black theta, which the question is asking us to do, we have to make sure the sign is correct. How do you know the sign of trig functions in quadrant 2? What do you use to determine that?
All students take calculus.
All students take calculus. So you have to, on top of this formula, you also need to know all students take calculus. And since we are in the second quadrant, we know that the sign is what? Positive or negative?
Sine's positive.
Sine's positive.
Everything else is negative.
Cosine and tangents are negative. Okay? So sine's okay. 6 over 10 is fine. This will be 3 over 5 if you reduce top and bottom by 2. But cosine and tangent, when we get the answers, we have to make them negative because it says in the second quadrant, sine's positive, whereas cosine and tangents are negative. Okay? All right, so let's go to cosine theta. So SOHCAHTOA says cosine is adjacent over hypotenuse. In this picture, adjacent is 8, hypotenuse is 10. So you have 8 over 10, which reduces to 4 over 5. Is that correct?
No.
No, what do we have to do?
Negative.
Put a minus, yes, because of this thing. Okay? All right, now we have tangent of theta, which is, according to TOA, is opposite over adjacent. At the opposite of this angle is 6. Adjacent to this angle is 8. Now this side is also adjacent, but this has a reserved name. That's a hypotenuse, okay? So when we say adjacent, we're really talking about adjacent leg, not the hypotenuse, okay? So TOA says opposite over adjacent, so that must be 6 over 8 with minus because of this. Always take calculus. And if you reduce top and bottom, it will be negative 3 over 4. Okay. Now, what other functions are there? Can you tell me?
Secant.
Secant. Okay, secant is 1 over cosine. Yes. So if you know the cosine, you can say secant theta is 1 over the cosine, negative 4 over 5. But whenever you have 1 over a fraction, that just means you take the reciprocal. The top and bottom just simply flips. So this is the same thing as negative 5 over 4. Okay, what other functions are there?
Cosecant.
Cosecant. Cosecant is 1 over sine, yes. So cosecant theta will be 1 over 3 over 5, which is 5 over 3. And then this is called reciprocal of tangent is called cotangent theta, which is 1 over -3/4, and you simply flip 3 and 4, and therefore the answer is -4/3. That's how you do it. Number 9, a wheel of 10 inches diameter is rotating at 48 RPM. What does RPM mean?
Rotations per minute.
Rotations per minute or revolutions per minute. To the nearest inches, what is the speed of a point of the rim in inches per minute? Okay. So let me try to draw a picture to explain to you what's going on. Here's a wheel with diameter 10 inches. Okay. And when this wheel rotates once, so let's say it's rotating this way, if it rotates once, then the point on the rim would be traveling along the circumference of the circle, so it would have traveled exactly the circumference of the circle. Okay? So what you want to think first is what one revolution is going to correspond to as in inches. So how far did this point travel if it revolves once? Okay. What's the formula for the circumference of a circle? Does anyone know? Circumference of a circle. What's the formula?
2 pi r.
Yes, 2 pi r, right? So we're going to use 1 revolution equals to 2 pi r, where the radius in our case is what? What's the radius in this picture?
10 inches. Oh, no,
5, because this 10 is the diameter, so radius is half the diameter. So it's going to be 2 pi times 5 inches, so that I know that 1 revolution is going to equal to 10 pi inches. Okay. But then we're talking about 48 revolutions. Okay. So 48 revolutions would equal to how many inches? What should you do? You can just multiply 48 both sides, right?
Yeah.
So you multiply 48 both sides to get 480 pi inches, which means 48 RPM is going to correspond to 48 revolutions per minute, which is going to correspond to 480 pi inches, because 48 revolution is same as 480 pi inches, and then you have minutes. I just remembered I forgot to bring my calculator, so I'll be right back. Now, in terms of the calculator, I see that it's 1507.96 inches per minute. And because the question says to the nearest inches, right? So what's the nearest inch here? 7.96 is closer to 8 rather than 7. You agree? Okay. So this is going to be 1508 inches per minute if you approximate, okay? Alright, so while this is the way you solve this question, often the questions might involve other kinds of units. So I want to show you how to answer this if the question was slightly different, asking in different units. So for example, what if the question was asked for feet per minute, how would you do that? How would you answer if the question asks, find the speed in feet per minute rather than inches? What should you do? Yes?
Divide by 12.
You divide by 12 because 12 inches is 1 foot, right? So this is the way you think. We know that 1 foot is equal to 12 inches. And therefore, if we have 1508 inches per minute, or I can just write it like 1508 inches per minute, you can say this is equal to 1508 inches per minute times 1 foot over 12 inches. Now, please notice the way that I'm using the equal sign here. I'm really saying that this is same as that. And on the face of it, that's a wrong statement, or at least a ridiculous statement, because I'm saying, oh, you multiply something by 1 over 12 and it's same as before. Nonsense. If you multiply anything by 1 over 12, it just becomes smaller, right? So at first it might not make sense to you, but because I'm using the feet and the inches unit here, this really is equal to what? This as a whole is equal to 1. Because 1 foot is same as 12 inches. Right? Now that would be wrong if I didn't have the units. Is 1 divided by 12 equals to 1? No, that would be very wrong, right? 1 divided by 12 is much less than 1. But if you put the units, because 1 foot is same as 12 inches, these are indeed the same quantity, and therefore that is equal to 1. So you should treat these feet and inches to hold some kind of a value. So in my mind, what I have is that like the foot itself is made of 12 inches. So this is really 12 times inches, which will actually, when you plug that in, and they can't cancel it, it does give you 1. Okay? So that's the way I'm thinking. And if you view it that way, what I'm writing down here is tautological. X is same as x times 1. Is that right? Is x equal to x times 1? Yeah, x is always equal to x times 1, right? So that's how you think. But then, what you can do is, I see inches here, and I see inches here. These 2 inches, I can treat them as canceling. And what that does is, I have feet on top and minutes on the bottom. So that's going to be 1508 divided by 12. Let's see. That's going to be 125.7. So if you do this divided by this, you get 125.7 feet per minute. Okay? So if the question was, find the answer in feet per minute, this is what you have to do. Okay. Another question. How would you answer this if the question was, find the speed in terms of feet per second? What would you do?
Would you multiply that by 1 over 60?
Yes, yes. That's because, see, I want 25.7 feet over a minute to be converted into same feet, but the bottom has to be in minutes. Not minutes, seconds. Okay? So, for that to hold, what you want to do is you want to cancel the minutes out and have the seconds to survive. How does that happen? Well, that's going to happen if I multiply this by 1 minute over 60 seconds. Right? 1 minute is same as 60 seconds, and you can see that the minute cancels, and now you have 125 divided by 60, and this is about like 2.1 feet per second. Okay. So that kind of gives you a better idea for me. Like at every second it's going 2 feet, kind of makes more sense. Okay? So that's how you calculate this. Okay. A right triangle has two legs of lengths 5 and 12. What's a leg of a right triangle? Yes.
Is it like, is it not the bottom piece, the two?
No, it is the bottom piece. Yeah. Anyone else?
And the height.
Height or the bottom? Just the two sides there are not the hypotenuse. Those are called legs. Okay? So if you have a right triangle like this, the two legs are here, and that's called hypotenuse. Right? Okay. Any right triangle has a unique side called the hypotenuse. It's the longest side. It's also at the opposite of the 90-degree one. Any right triangle will have a hypotenuse that's distinguished. But the other two sides, you just call them legs. Okay? All right, so it says that one side is 5, the other side is 12. Okay. Now, how would you get this length? Pythagorean theorem. So let's call that C. 12 squared plus 5 squared is equal to C squared. 12 squared is 144. 5 squared is 25. So that C squared would be, this plus this gives you 169. And C would be square root of 169, which is 13. Okay, so that's going to give you that this length is 13. Now let's carry on and read the question. What is the cosecant of the angle opposite the side of length 12? Okay, where is this angle at? It's at the opposite of this side, so this must be angle theta. And the question is asking for cosecant of theta. Now, cosecant of theta is the reciprocal of
1 over sine.
sine. It's 1 over sine. Yeah, it's the reciprocal of sine. Now, what is sine theta from the picture? What's sine theta from the picture? What is the opposite of theta? 12. What's the hypotenuse? 13. So it's 12 over 13. And now that you have 1 over 12 over 13, the final answer will be 13 over 12. Because it's the reciprocal of 12 over 13. So this is the answer. Let's look at the next question. It says convert 4 pi over 5 radians into degrees. How do you convert radians into degrees? What do? You multiply by? No, pi over 180 is when you convert degrees to 180 over pi. Okay. Or better yet, another way is to just say pi radians is 180 degrees. So you can just look at this and just replace the pi by 180 degrees. You get the same answer slightly more quickly. Okay. But anyways, if you cancel the pi and multiply them together, it's the same effect. This is exactly what you would get if you just took the pi and replaced by 180, right? And then 180 divided by 5 is 36. So that's going to be 144 degrees. Okay. Now for the next question, it says convert 144 degrees into radians, which we already know the answer for, but nonetheless, let's try to see how that one works. To go from 144 degrees to radians, what do we multiply?
Pi over 1.
Pi over 180. Degrees cancel. And see, 144 and 180. 144 is 12 times 12. 180 is 3 times 60. But 60 is 12 times 5. And I like that because then I have 12 on the top and also 12 on the bottom, which I can cancel. Cancel those. And now you have 12 divided by 3. What's 12 divided by 3? 4. So you have 4 pi over 5, exactly same as what we started with. So you can see that how you can go back and forth. Okay? You can go from radians to degrees and degrees to radians. Okay. A child rides his bicycle at the rate of 9 miles per hour. If the diameter is 6 inches, find the angular speed of the wheels in terms of revolutions per minute. Okay. All right, so let's try to decipher this by thinking about the units involved here. So first, 9 miles per hour is what you're given, right? So the miles is the unit for lengths, and hours is a unit for time, right? So let's try to think about that. All right. Then there's the inches, 6 inches, which is another unit of time, right? Another unit of length. And then there's the revolutions, something revolutions per minute, which means you have revolution, but although revolution is the unit for the amount of rotation, which is it really has to do with the angle, but we're going to misuse that and think of this as the length. Okay, 1 revolution, we want to convert it to the corresponding length. So that's that part is slightly not according to the original unit, but I'm just going to think of revolutions as length for this solution. And then minutes, that's the unit for the time, okay? So what I need to do is I need to know how to convert miles to inches, and also inches to revolutions, and also hours to minutes. So those are the things that we should be working towards too, okay? So first of all, what is 1 mile equal to in inches? Well, that I don't know. I do know that 1 mile is equal to 580 feet. By the way, this is not a common knowledge, so if I have a similar question on the exam, I will be giving this to you, okay? If you don't see it, then raise your hand, I'll tell you during the exam, okay? All right, so 1 mile is 580 feet, but then 1 foot is same as how many inches?
12.
12, that everyone should be knowledgeable of, okay? All right, so that's how you convert miles to inches, that's good. And then 1 hour is what? 1 hour is how many minutes?
60.
60 minutes, so you write that down. And the slightly unconventional one is I need to know what 1 revolution would correspond to in terms of inches, okay? So for that, we have to use this information, right? If the diameter is 6 inches, what's the circumference that corresponds to 1 revolution? How do we get the circumference? What formula do we use? 2 pi r is the formula for the circumference, where r is the radius. What's the radius of this wheel?
3.
3. It's half of the diameter, so it's 3. So I know that 1 revolution is 2 pi r inches, and 3 should go in there because that's half of 6, okay? So we see that 1 revolution is going to be 6 pi inches. Okay, so once we know these identities, then what we need to do is just start with 9 miles per hour and just keep changing the units by multiplying whatever that's equal to 1. Yeah, yes?
Is 1 rev always going to be the diameter times pi?
Yeah, 1 rev is, so there are 2 formulas for circumference of the circle, which is 2 pi r, or pi times diameter. You were used to learning the circumference as pi times diameter way back in elementary school when you first learned pi, okay? But then later, when you get to precalculus, 2 pi r kind of takes over. So I'm kind of using 2 pi r, but it's always pi times d. So we could just have said, oh, 6, since the diameter is 6, it'll be just 6 times pi. So that's another way to get it, okay? Good. All right, so you have 9 miles per hour multiplied by, okay, so my first goal is to change miles into feet. How do I do that? What do I multiply this by? To go from miles to feet, what do I do?
Uh, 5,000.
What should I write on the top?
5.
No.
Oh.
I should put 5 to 80 feet on top and 1 mile on the bottom. Now, why would I want to do that? That's because if I have the mile in the bottom, that's going to cancel the mile on the top. And after these are gone, now the unit for the length will be feet. Okay? That's the way you should think. Okay? But feet is not what we want. We want inches. So how do you go from feet to inches? We multiply by?
Just do the same thing.
Okay, so what over what?
12,
12 inches
over
over 1 foot. Because then foot and foot will cancel. And inches will survive. But that's still not what I want. I want revolutions per minute. So I want to convert that to revolutions. So I want to cancel the inches out. And in place, I want the revolutions. So what over what? 1 revolution over 6 pi inches. Okay, it's not 6, it's 6 pi. Okay. All right, so after all this, after the cancellation, we'll see that I end up with revolutions on the top. Perfect. However, the bottom still has hours, so I need to change to minutes. So what should I do? What do I multiply?
maybe 1 hour, 60 minutes.
1 hour on the top, 60 minutes in the bottom, so that this hour here is going to cancel with this hour, leaving you with 60 minutes. Now look at what's on the top, what's on the bottom. You see that it's 9 times 5 to 80 times 12 divided by 6 times pi times 60. And it should be revolutions per minute, which is exactly the RPM that we're looking for. Okay? So you want to put this in there. Now, on your calculator, some calculators allow you to put everything into the calculator at once because it supports parentheses. Others don't. If you have a calculator that do not allow parentheses, then you have to calculate this on top separately, write the result on a piece of paper, calculate the bottom separately, write the result on the piece of paper, and then do that. Those two numbers you have to divide. That's how you have to get the answer. On calculators like this, you can simply enter what you see, 9 times 5280 times 12, and then divide. But there's more ways to get the wrong answer with these kind of calculators, which supports parentheses, because a lot of you will forget to put a parenthesis around here. Okay, since the entire thing is being divided from here, you need to put a parenthesis. If you fail to do that, you're going to get it wrong. Okay, so although the calculators that allow parentheses are easier to use, it gives you more ways to fail. In fact, that's what happens a lot. When I grade exams, a lot of people will get this wrong because they forget the parentheses. All right? Okay, so it'd be 6 times pi times 60. And the result is that you get 504.2 revolutions per minute. Okay. So that's what. A contractor wants to know the height of a building, and from 99 feet away from the building, the angle of elevation to the top of the building is 43 degrees and 26 minutes. Find the height of the building. Okay. To explain what's happening here, here is the building, and you're 99 feet away at a point, and from the ground, you look at the top, and you measure this angle, which can be done, right? And it says this angle is 43 degrees and 26 minutes. Given all this, the question is to find the height of the building. Okay. One thing that I forgot to talk about during the class is that there is this thing called minute, which is not 1/100th of a degree, but 1 minute is what? 1 minute is 1 over 60 degrees, okay? And those of you who already took navigation or are going to take navigation will be using that unit a lot. When degrees are used, a lot of times things are measured in minutes. So if you have 43 degrees and 26 minutes, what's the height? That's the question. All right, so we have this right triangle. Of the three trig functions, which one should we be using? Of the three, so, ka, toa, which one should we use to get this h involved?
Sine.
So,
Sine would require this hypotenuse, and we don't know that.
so tan.
Tangent. Tangent is opposite over adjacent, right?
Ah.
So you can say that tangent of 43 degrees and 26 minutes is equal to opposite, which is h, over adjacent, which is 99. Okay, that means if you want to solve for h, you have to multiply by 99 both sides, so that the height that we want to know would be 99 times tangent of 43 degrees plus 26 over 60 degrees. Okay? So you have to convert minutes to degrees by dividing 26 minutes by 60 degrees. Okay. Now, one big thing that you have to remember when solving these kind of questions is that you have to put the calculator in degree mode. And since this is different from calculator to calculator, you really have to figure it out before you come to take the exam with it. So for example, this calculator that I brought here has DRG on the top left. If you click that one, then it says DG, RAD, GRD. I don't know what GRD is for, but I just have to scroll to the DEG and press enter. That gives you the degree. Okay. Now some calculators would have mode, MOD on the top left. You click that, that will give you a menu that you can choose degrees or radians. Some of them would have something like DR, something like this, meaning that degree and radian mode, you just convert between the two. So it depends on the calculator, but you must know how to convert between the degree mode and radian mode, because on this next exam you'll be using both, okay? So assuming that you did put everything in degree mode, now all that's left is just to punch this into the calculator. So let me do that. 99 times tangent of 43 degrees plus 26 divided by 60. And if I do that, I get 93.73. So 93.73 feet. And it kind of makes sense because, see, if this angle is exactly 45 degrees, then it will be an isosceles triangle, so this height will be 99, right? Since this angle is slightly lower than 45 degrees, we know that the height should be slightly less than 99, so 93.73 kind of makes sense. Okay, so that kind of judgment is indeed quite helpful. Okay. All right, so this question 14 says there are point A and then another point B. They're trying to build a tunnel. And it says that from this separate point C, if you look to A and B, this forms 90 degrees. AC is 210 miles, BC is 497 miles, and from this picture it's asking for this angle B. Okay. Now, with respect to this angle B, which one of the three trig functions is easiest to calculate? Sine, cosine, or tangent? Which? Tangent, because tangent of B is opposite over adjacent, so that's going to be 210 divided by 497, right? So we can easily get the tangent of B. However, the question is asking for B itself. So from here, how do you get the angle B?
You have to do the reciprocal.
No, it's not the
Oh, no,
reciprocal.
you have to
It's
do the minus 1 for
what is that? That's the inverse function,
Inverse.
okay? Yeah. So the reciprocal of tangent function is cotangent. That's not what we want here. We want to switch the input and output, right? We want to use the inverse function. What is the inverse function? Inverse function switches the input and output. This output becomes the input of the tangent inverse function, and this input to tangent now becomes the output. Now if you do that, you see that by doing this calculation on your calculator, it's going to reveal the angle B, right? So that's the idea. Let me do it. And again, make sure that you're in degree mode, because in these work problems, they require degrees. So what I'm going to do is I'm going to do second tangent, that's the tangent inverse in this calculator. 210 divided by 497, and that gives me 22.9 degrees. So B is about 22.9 degrees. Next question, find the arc length intercepted by theta equals to 83 degrees on a circle of radius 143.58 inches. Also find the area of the sector formed by the arc. This question requires the formula SOAR. It's really S, the arc length equals to theta times R. But, you know, assuming that you don't know Greek characters and you just read this like a O, you can read this as SOAR formula. It's just a fun and easy way of remembering that formula, okay? So that's the arc length formula. What about the area? Area is 1/2 RS. And this really looks like the triangle area, which is 1/2 base times height, okay? So those are the ways to remember these formulas. Let's try to apply them. So here's a circle of radius 143.58. And here's the angle of 83 degrees. And we're looking for this length, S. And to get that S, we have to use the SOAR formula, S equal to theta times R. But the catch here is that this theta must be in radians, or else this formula doesn't work, okay? So you have to convert 83 degrees into radians. How do you do that? 83 times. How do you convert degrees to radians? You multiply by?
Pi over 180.
Pi over 180, yes. And then times radius, which is 143.58, right? Okay, so you just plug everything into the calculator and you get the answer. 83 times pi times 143.58 divided by 180. And you get 207.99, so about 208. Okay, now for the area, it's 1/2 times the radius, which is 143.58, times 208. Okay, so we have to multiply this by 143.58 and divide by 2. You get 14931.8. 14931.8. Okay, so that's the answer. Okay, so let's try to find the reference angle. Since radius is a little hard to visualize, let's try to change this into degrees. So in terms of degrees, pi is 180 degrees, right? And you divide this by 5, you get 8 times 180 divided by 5 is 36, and 36 times 8 is 288 degrees. Okay. Now that's easier for us to know because 288 degrees is more than 270 degrees, and it's less than 360 degrees, right? So it's like this. Here's 288. And the reference angle is here. So this much is 288, and the reference angle of 288 is this angle. It's the closest angle to the x-axis, right? Now, how do we get this angle? How do we get this angle?
Subtract the 360.
Subtract from 360. So you can do 360 degrees minus 288, which gives you 72 degrees. Right? But because the original question is given in terms of radians, you have to convert back to radius. How do you convert to radius? You multiply by pi over 180, right? And once you've simplified this, you're going to get 2 pi over 5. Now there's another way to get the same answer without having to go back and forth, which is if at this point you know that this is in quadrant 4, you just have to subtract from 2 pi. So a second method solution 2 would be just simply do 2 pi minus 8 pi over 5. And because 2 pi is 10 pi over 5 minus 10 pi over 5, and then 8 pi over 5, and now if you subtract, it's 2 pi over 5. So that's a bit faster than having to subtract with numbers and convert back to radians. Okay. All right, so what about this one? Well, this is way out of the 361. So for this one, if I want to figure out what the reference angle is, I first have to figure out the coterminal angle between 0 to 360 to visualize where it is. Okay. So what I'm going to do is I'm going to keep adding 360 until this becomes positive. So one thing you can do is you can use your calculator to add 360 to this one, another 360, 360 until this becomes positive. That's one way to do it. Or I know that 360 times 2 is 720. So let's start by adding 720 to this, see what happens. So this is going to be 720 minus 1324, but that's same as negative 1324 minus 720. What's that? 2 minus 2 is 0. So 13 minus 7 is 6, so I have negative 604. Oh, that means I can add another 720. So let's add 604 plus 720, which is, what's that? That's 116? Yeah, 116 degrees. Okay, so this is coterminal with this. So these two angles are coterminal angles on the unit circle. So you're right here, 116 degrees. Okay. Now once you draw it, it's easy to see what the reference angle is, right? What's the reference angle in this case? You have to subtract from what?
180.
180. So you subtract from 180, and that gives you 64 degrees. So that's the answer. Because the original thing is asked in terms of degrees, you should answer in degrees. Okay. All right. For this question, if I want to know A, which trig function should you use? Sine, cosine, or tangent? Which one? If I want A, I want tangent of 32 degrees equal to what over what? 8 over A. Therefore, I can multiply A both sides. And now you can divide both sides by tangent 32 so that A is equal to 8 divided by tangent 32 degrees, which now can be calculated using your calculator. Make sure you're in degree mode here. 8 divided by tangent 32 degrees. And that's 12.8. Now, what about b? To get b, what should you use? Sine or cosine? Which one? Well, it's easier to use 8. I could use this a that we just figured out, but it's easier to use 8. Okay? So this is opposite, and this is hypotenuse, so sine is more appropriate. Sine 32 degrees is equal to 8 divided by b. Multiply by b both sides. And now you divide by 32. Divide by sine 32. And if I use the calculator, 8 divided by sine 32, I get 15.1. Okay, so these are the lengths of A and B.